both the points, characters of the lines. Okay? And this is very useful for document processing or document synthesis. So if I just go dilating or closing this image, it is more horizontal surface. Small one because I don't know what is the size of the surface. Just arbitrary small surface. Okay? Just close it and I got this result. The number of components is more or less same. So this is not a good one. I use a little larger structure element. Okay, probably most of the words are marked a little more larger than the now the lines are marked. Now if you move on, increase the size of structure element, don't check it. Okay? So I get the result is step. So I can use some opening operator and that will remove some small photocells here and there, and that makes a very beautiful horizontal line for each hormone being taken. Okay? We can do it for the slanted line. Just by using some closing operation, I can close the lines. Okay. So these are the very simple examples. These are very simple examples of binary morphological. When you use the graphical morphology, what you do, when you told that this graphical image is sort of a three-dimensional object where X, Y, and the effects versus the value are taken as a three-dimensional point. So it's an object in a three-dimensional space. And now it starts extending this binary morphological operator to the graphical morphological operator by using a similar dilation and division operator. So just get an idea whether it is a mathematical definition and the data. Suppose this is my one-dimensional function of X, and this is my structure element, exactly signal of what it means, I can make it a one-dimensional, two-dimensional binary object. How? Just think of the umbra or the shadow of it function up to the x-axis. So this is my binary object. Okay? Forget about all of the things. This is a binary object. And this is my structure element. Now I can simply dilate that object within the structure element. I can take the outer one like this, and then from that binary object, I can just take the upper boundary to get back the dilated. So the red was the dilated signal or the dilated function, the black one was the order. Similarly, we can do the same thing on this binary object, same that with a simple binary setting operation, and then this is the resultant one, this black portion, and then we take the upper boundary to get the eroded. So this is the graphical direction of erosion. But we do this operation by means of binary morphological operation. No new operation or no new things are being released. So these are the definitions, and let me now suppose this is my original function. Okay? If I dilate this original function by small horizontal structure, what will happen? It will dilate or expand in the horizontal direction. If it erode, it will shrink in the horizontal direction. So this red one is the dilated one. Blue one, we will see is the eroded. If I take the difference between the red function and the blue function, I will get zero everywhere except at these two places where they are really a change of the edge. And this simple idea can be applied for the any edge detection operator. Okay? So edge detection, but you do it the carries operator, these and that, you can do simply dilate, erode, take the difference, we can take the difference operator, and either you can threshold, you can change, it will get almost as good as. Okay. Here's another opening and closing operation. So this is one example of the document page. As Tushar was talking about the page contains text and graphics and photos. I want to separate them out, suppose. I just take the opening and closing of these two operators with a small structural element. What will happen? This small structural element will fill up all the small white portions in the character area, but almost doing nothing at this portion because the text is very small. If I open it, then all the black portions are removed from the image because there are very small black strokes or black particles. But the original graphics will not be affected much. So if I take compare these two with this one, where you can see where the maximum changes, then we can easily find a separate out this portion from the text portion and the graphic separate. So here the more detailed algorithm, I'm not really going to that. Okay. So what it says is when you open an image or an object, some portion of the object are removed or some small objects are removed from that. So open image is always the smaller or the lower than the original. So if we take the difference between the original image minus the open image, I will get only those residual parts which are removed from the image due to the opening of it. Similarly, if I close the image and subtract the closed image from the original one, I can get what is appended or added to the image. Just here, this is the original function. If I open the structure element, this portion of the function are removed or chopped off from the function. If I take the difference from this and this, we can get this as the right top end of the different portion of the image. Similarly, if I close, some of the holes of the values are filled up, and there, when there is a difference, I can get the portions are here in the image. And these informations are used in case of defining the magic scale. So far, we are talking about the structural which are of the some shape and some size.